he gave it the name. It's a manual, and it's got a red interior, so red shift, that's the little bit. But the second meaning is, since it's the license plate, it's on the tail, it says red shift, so bring your physics into play here, right? So he says, you should have a blue shift license plate for the front. And I go, okay, we can do that too. But let me get this up and running. Not that one, this one. Function F5. Something like that. I like to look at the screen, but that's so dang high. How do you guys deal with that?
Sit all the way in the back.
Sit in the back? I mean, I'm supposed to use my kiosk to help my prompt. Hard to point though. It's like, look here. This has a laser, but I'm sure the screen doesn't like that. Yes, it is a little bit. Okay, it's a green one. So I can either do that laser or I can do the virtual laser, which is what I normally do because we do Skype meetings a lot. And it's like, look here. It's like, wait a minute, you're not looking at my screen because you're across the world. Normally that's what we end up doing. Okay. Well, there's a sign-up sheet that will go around eventually, but voila. It's in the back. You guys know how to get credit for your classes, right? So, just start anytime? You ready to go? Okay. Well, welcome to my hour of fame, I guess. So, my name is Chris Hoffman. I'm from Cummins Incorporated. I'm one of the chapter secretaries of our local Incozy chapter for Crossroads of America, and I do all sorts of other fun stuff. But let me tell you a little bit about myself. Just in general, to give you guys an idea of who I am, what I do. So I'm been employed at Cummins for about 22 years now, down in Columbus, Indiana, just south of here, a couple of hours. So I also am if you look up Incozy for systems engineering, one of the certified professionals, which basically means that I've worked in this field for a while and I know the lingo and the terminology and the processes and such. So the stuff that you guys are doing for EPICS in terms of how you walk through a product development process, same sort of stuff, we just use slightly different terms here and there. One of the things that I'm currently doing is that if you think about all of the different tools and stuff like that that you use in engineering or might be using in engineering, is for Cummins, I help guide the strategy of that. And so figuring out, okay, well, what tools do we use to do requirements management with? What tools do we use to do finite element analysis with? What tools do we use to do whatever, testing with? I help guide the strategy of that. So if you've seen in any of the in the industry, digital thread, digital engineering. Purdue here at the Polytechnic Center with Dr. Nate Hartman has a big thing in terms of the PLM Innovation Center, which is now the Digital Innovation Center, I think, Digital Experience, something or other. But we participate in that as a company as well. I have had some fun with a few different things, but there's my family. Just to give you an idea, my son here is actually a second-year engineering student here at Purdue, so I figured he's going to buy me dinner tonight, so we're good for that. One of the products that I'm most proud of is I actually got to do the after-treatment system, lead the technical development of that for the 2010-2011 model year cab chassis Dodge Ram truck. And so this is an F5 or a 5500, a 2-ton truck. Side bonus of that is that I got to drive around a truck like this for about 3 years during the product development. So as an engineer, I actually got to experience the product that I was doing. A little tougher for some of my colleagues and peers in aerospace. You don't really get to fly on the rockets or stuff like that, or sometimes you're on the planes. A friend of mine actually was a flight engineer, so she had a lot of fun with that. I also am a farm boy of sorts. So this is a 1935 Case Model C tractor that my grandfather had bought new when he was probably about 18 and did some contract farm work with that. I restored that and have a trip bottom plow for that and have some fun. And then I have an old boat that also he got in the 60s. So it's a little bit of fun. Wooden boats or boats in general are kind of one of those things. It's just a big hole in the water that you throw money into. So it is one of those things that, but it gets hands-on. I get to actually do some work with that. So I'm going to give a quick overview. Here's the agenda for tonight, this afternoon. So I'm going to talk a little bit about Cummins. Any of you folks know Cummins Inc. 1, 2, 3-ish. So we do all sorts of different things. I'm going to teach you a little bit about that, give you an idea of, okay, what is Cummins? What the heck do we do? We're here in the state, so tell you a little bit more. My challenge, I'll breeze through that a little bit, and then talk through some of the real point of the topic tonight is principles of architecting, but really principles in general. And then anytime you have questions, there's a small enough group of us here, feel free to just raise your hand, shout out, whatever, and say, hey, I've got a question about that. Hopefully make this enough, a little bit of entertaining for you so you can figure out, get some questions answered on how do I apply these things in daily life? Because they really are principles. They're good enough you can use them about any time. So Cummins is, we're 100 years old. We are in our 100th year. We've been doing celebrations around the world, but for the most part, they're diesel engines. We grew up with diesel engines back in the early 1900s. Interestingly enough, we didn't earn a profit until 1937, so Plessy Cummins was quite a persistent fundraiser, I guess you could say, with Dr. Irwin, or with Irwin Miller, who was actually funding our company for many years. And so it's kind of interesting. One of these ones where in 1929 there, he took a used Packard limousine, stuffed a diesel engine in it, upfit it, took his financier in a ride and said, hey, this has got a lot of potential. Give me your cash so we could keep working. So they kept doing that, and it was it was a really good, savvy marketing guy in terms of proving out the engineering. And so some of the stuff that you all do, or maybe are starting to learn how to do, is build a prototype. Doesn't have to work perfect, but give it a try. You can either model it, or you can build some, fab something up, make a test something and say, hey, I think this has got some merit. And the purposes of building that kind of sample is not necessarily to have a finished product, but it's to give an experience to your end users to say, hey, this is kind of what it's going to do. What do you think? And it's more of a learning opportunity. Dip your toes in. So in terms of size of Cummins, we're quite big, actually. We're over 62,000 employees now, all over the world. We touch pretty much every country in the world in terms of servicing and distributing our products. We're about, last year was $23 billion in sales, so we're quite large. But the interesting thing is that we have small groups as well. So if you're a type of person that likes to be in a small group, we've got small portions of our company that also does that. Around the world, we do manufacturing pretty much everywhere in terms of, here a lot in the U.S. U.S. is our biggest market. The semi-trucks driving down the road, Dodge Ram pickup trucks have our 6.7 liter in them. The Nissan Titan has a 5-liter V8 diesel in it. And then we make engines all the way from about 2.8 liters up to 96 liters or so. So 50s of horsepower up to 5,500 horsepower or so. And they're in train engines now. So the Siemens Charger locomotive has that huge engine in it. We call it the Hedgehog. Quite fun. So in terms of different areas of the company, what we do, engines, all of the components that go on the engines, the power systems like power generation, backup power for data centers, backup power for hospitals, buildings such as this. If there's a gen set for emergency power, or even prime power, we do that. Over in Africa and a few other places around the world, we actually are the primary source of power for some folks' homes and their overall like miniature cities, and so that using distributed generation there. Some of the new technologies that we're getting into. Oh, question. Yeah.
So that's telling me Purdue industrial engineering majors to get jobs at Cummins, not just mechanical.
Oh, absolutely. Yeah. So when you're looking at our manufacturing base, our distribution network, so logistics, all sorts of different engineers and we've got them all. Even aerospace engineers, we've got aerospace engineers, Bob, right? So in terms of, hey, we make some really high-end turbochargers You may not think about that, but hey, these suckers spin at close to 100,000 RPM, and think of the forces that you have to deal with and all of the finishes that you have to deal with for some of that to work, and really high temperatures. So we're dealing in the same sort of high temperature materials like Inconel and all that sort of stuff, trying to figure out how to make those things work and last longer in a fairly nasty environment. Let's see, so new technologies as well. So diesel is not going to be here forever. Some sort of combustible fuels probably will be, but in terms of we are trying to displace ourselves in terms of certain markets. And so if you think about electrified powertrain, alternative fuels like biofuels or synthetic fuels, you can still burn these things, but they're actually synthetic as opposed to dinosaur-based. And so there's all sorts of fun stuff going on there. Distributed power, the control systems that go in that, all the switch gear to figure out how do I quickly switch from grid power to backup power, and all of the electronics, all of the contactors, all of the switches, all of the control systems that make that work. In terms of digital and, hey, there's an app for that, building apps for your genset, and so you can actually, and your piece of equipment, whatever it might be, to actually say, hey, I can look on here and say, hey, I can lock or unlock my doors on my car from my phone. Well, you can also get diagnostic troubleshooting codes, telematics data fed back to your phone to give you suggestions on when you need to take action in terms of a maintenance event or how to drive better. I think we're actually even doing some stuff here at Purdue with, have any of you guys seen that little food delivery self-guided doohickey thing while driving around here? Yeah, we're kind of involved in that too. And so one of our digital products ventures is looking at that in terms of, microservices, self-directed, autonomous driving stuff. So we've got fingers in lots of different places.
What was the new prime mover?
So new prime mover, that's kind of getting into the powertrain of choice. And so if you think about the prime movement of powertrain buses, we've got everything from diesel, natural gas, electric, hybrid, all versions of hybrid in terms of, do you want parallel electric or do you want hybrid, full series electric. So it's kind of that sort of, it's getting into some of that. Really it's kind of the by powering a more prosperous world. And so kind of our vision statement here is, how do we actually do that? One of the things that really excites me about Cummins is we're a large engineering company, yes, but these values are probably the things that have kept me at Cummins these 22 years or so. If you think about just the integrity, the diversity and inclusion that we have in our company, we have been on the top notch of inclusion metrics and awards and all of that sort of stuff. That's really impressive to me, and it's part of my value system as well. Caring and excellence and teamwork. So those of you in the EPICS program hopefully kind of aspire to some of that same sort of stuff on how do I care for the environment, how do I care for my community. Cummins really kind of exudes many of those same values. Next slide, right into that. So some of the corporate responsibility, this is just some of the stuff that we've done. We sponsored, actually tomorrow's Thursday. Tomorrow I'm going to be packing school lunch bags or school backpacks for one of our local schools in Columbus area. So that's one of my community hours that I'm doing this year. It's actually my second event that I'm going to be involved in. So all sorts of fun stuff there. Environmental sustainability, again, yes, we are primarily a diesel engine or diesel power company, but in terms of carbon dioxide reduced overall, you think of all of the Paris Accord and all of these, how do I get, with the global climate change and all of that sort of stuff, we are attacking that as best we can, going after how do we deal with that, how do we help our communities, because frankly, if there's not a community, there's not much product for us to sell if there's not a community, so it's a bit in our own interest to help with that, but also just making our communities better. Lots of different markets. We are primarily what you would call maybe a tier 1 supplier, so you don't see we don't sell end products too much directly to consumer. We do have our filtration products that if you are buying sort of things like filters and whatnot, you might see our Fleet Guard brand or that Cummins brand out there. If you have generators, you will see the Cummins gensets. It's usually green. Used to be called Onan gensets. So we are in probably 90% of recreational vehicles in terms of gen sets that are in like RVs and stuff like that. You'll see our generators in there, but we're all over the place in terms of markets that we power. And we really are at our best when the industry is shifting. Give us a high regulation to meet, give us a challenging target, and that actually invigorates us and gets us one of our competitive advantages against others in the industry. So, any questions on who Cummins is? So, give us a look-see. We do recruit on campus, so come and find our folks. They'll be happy to talk with you about internship opportunities and all sorts of different things. So my challenge and opportunity is, I could say, hey, I need to get from here back home tonight. And so one of the things that we do with our engineers is we say, here's a bunch of things that you need to get your job done. Go for it. Here's the stuff. I can pile all these parts in a room and say, here you go. Go down to South Indianapolis today. This probably wouldn't get you very far. You'd have to assemble it all, put it all together, and actually get a vehicle hopefully out of this. You may not have all of the parts you need. This is the challenge that I'm working through in terms of the engineering space right now. I'd rather be able to say, hey, take this, put some gas in it. If you really, maybe you may not need gas, but at least you just have to drive yourself from point A to point B. This is the problem set that I'm going after, trying to get after. How do I make sure that the engineers in my company have the tools that they need to take a problem set and get a solution out of it? You know, how do you create something? You are learning in your engineering career kind of hey, here's the bits and pieces that I need to go from point A to point B. It may not come to you in all one nice package. It's really kind of handy if you say, hey, here's a formula. Here's your factors that you need. Plug it in. Here's the answer. Calculate it out. It's already pre-programmed. All you have to do is give the inputs, and it gets the output when you click the go button. Engineering is not quite that clean, of course, but we try to make it as best as possible to get you all of the stuff that you need. And so that's kind of one of my challenges at Cummins, is to figure out how do engineers get all of these different things, and this is just a directional diagram to figure out, okay, well, really I want you to be able to use a tool that has some capabilities to create, read, and update, delete information. That's actually going to end up getting you satisfying a plan so that my enterprise is happy, so that we make money. Frankly, so that we actually can provide value to the customer and so they can make money, whether it's shipping goods, Amazon shipping goods from here to there, Microsoft making sure that their data centers are powered all of the time, or a ship sending passengers or goods from point A to point B in the ocean. We want them to be able to use that and depend on our power for that. And so systems engineering gets after that. And it's just an approach to figure out, how do I take and simplify the complexity of all of these integrated systems that we design. This computer, my smartphone, super complex things, but you can give these phones to pretty much anybody nowadays. Even, when my kids were really young, I could hand them a phone and they could figure out and do something valuable with it. They didn't know all of the complexity of the parts. They didn't know all of the complexity of the ecosystem, the purchasing, and all of that stuff behind it, but it really got into some of that. And so I'm getting after, how do we improve the direction and knowledge of our engineers so that they can make more products? These products are just getting more complex. So getting into the principles of architecture. So principles, almost always valid. What I want you to think about over these next few slides for the rest of my talk today is figuring out, okay, well, how can I connect this to something that I do? Something that you do every once in a while or day in and day out. These principles should resonate somehow with you. I'm going to tell you my story of kind of how I interpret these and how I use them in my daily career and even just life. You should be able to write your own story and have your own narrative going on in your head on these principles, because they are long-lasting underlying fundamentals. The methods, or the how to do these things, those are really grounded on principles, but these are the things that you might find in your company policy statements, or in here's how you do something. It's going to be written down in a work procedure or something like that. And then the tools are the actual, I can embed a method in a tool and say, hey, plug your stuff into this tool, hit the go button, it's going to get you an output. So I'm gonna give you a selection of principles. There's 5 of them that I go through. We'll see how the time goes. I might just skip around a little bit, but we should be okay. So the first one is kind of the keep it simple.
Excuse me,
Yes.
could you address the numbering? It seems kind of 2, 3, 5, 6, 9.
I've got 11 principles. I picked out 5.
All right, so it's not from Covey's.
These are not
7
Covey's
habits,
principles,
it's just
7 habits.
these are good, okay.
These are Chris's Journal of Engineering of Architecture principles that I did as one of my class assignments. So I don't know how this works here at an academic institution, but I did my homework on this about 5 years ago. Wrote this journal, wrote this paper. I sent it to Pam Brown, so she's got a copy. I don't know if she distributes stuff later on. I'd be happy to share it if you don't, but it should be part of the package.
You should email it if you tell her to.
Cool.
She'll email it afterwards.
So after this presentation, you'll get a copy of this in PDF form, this presentation, and the principles paper, which has all 11 of them in it, AKA Spinal Tap. Right, so those of us are, kids probably don't even have anybody heard of the Spinal Tap movie? Oh God, no. You have. Look it up sometime on YouTube. So, it's a hair band reference from a long time ago. Showing my age. Anyhow, the numbers these are just ones that I picked. Thank you for the question. So the cost of decomposition. So keep it simple. So one of the things that we do as systems engineering is we like to bucket things and group things and put them into smaller packages. So decomposition is as you learn, right? I can take this one on the top left and say, hey, there's actually 2, 3, 4, 5 boxes there with 6 connections. If I chop it into 2 and say, hey, this is group A and group B, now I have 2 things with 1 connection. The challenge there, though, is that on the surface it seems much simpler. If I can actually abstract up a level and say, hey, this is group A, group B, then I've got some opportunity there. The challenge, though, comes in terms of, hey, as things expand out, this is more like a fractal, right? It just repeats and repeats and repeats and repeats. You really need some help to understand your full system. So as you are, the kind of the tagline quote here is make everything as simple as possible, but not simpler. Because you will have some challenges if you get it one way or the other. And it's somewhat of an art form, but you got to try to figure out what's the happy medium. One of the challenges with these things is, and really this is getting into some of the graphics here. Really, the descriptive version of this principle is really the human mind. Your head can really better understand relationships and interactions between groups and whatnot when with a minimum set of elements at any one time. It's kind of, if you look up some of the research, it's like why our phone numbers were like 7 numbers long. At least I'm told with Bell Labs, right? That was kind of one of the things in terms of, hey, that kind of is about the right number of things that you can remember. So if you look at one of the decent architecting principles is keep your numbers like around 5 to 10-ish, 5 to 7-ish, somewhere in there. And you can usually deal with that sort of number of elements at any one time and the relationships between them. It's kind of roughly in that space. You guys started working in teams yet in your classes? How many folks are in your teams? 2, 3, 5, 4, 8? What? Roughly? 3? Okay. So is it easier to work alone or is it easier to work with a team? Kind of depends, right? So one of those things that at least I find is that, I find it much easier if I can do it all myself, then I will. And I have to fight that, when I get into a team of people, right? So but if you have a team of people all heading the same direction, you can go a lot farther, a lot faster. And it's kind of one of those you'll find in, team building exercises and all sorts of things. You kind of end up in that space trying to poke at that experience. The challenge with working in teams, and as you separate groups and say, hey, this group A, you go off and do this work. Group B, you go off and do that work. Group C, you go off and do that work. Let's come back together in a couple of weeks and put it all together, and it'll magically work, right? It doesn't always work, right? It like stumbles and, wait, I thought you were doing that. No, you were doing that. So you have to be more prescriptive with what people do when you get into that. So one of the ways prescriptive is, this is kind of the command statement, is, hey, when you're presenting concepts, systems, et cetera, try to present it with a minimum set. And use abstractions, averaging, essentially, right, to get you up a level so that you understand and can simplify your point. Get a mental model. And so if you see in the top there, that V diagram, your product development process, your syllabus that you have for your classes. Usually you have a rubric or something that says, here's how you're going to be graded, right? Here's your list of requirements, that's your rubric, of, hey, how you're going to be graded. You're going to have some risks in there in terms of, did I get enough sleep last night? How did I eat enough? Did I not party too hard over the weekend, or whatever it was? And you're going to create your homework, those items, those artifacts. You're going to create your answers to the questions and take the quizzes and tests and stuff like that. So you guys have got midterms coming up here next week, right? Starting up here, right? So you're going to have an opportunity to be tested against the requirements of your class. So and then every once in a while you're going to get asked for, hey, how you doing on the status? Did you get your stuff turned in on time? Did you actually complete your work on time? Did your project get done on, whatever it might be? How far along are you in terms of completing your requirements for your coursework? We do the same thing in engineering. It's, hey, what's your list of requirements? What should this product do? How much power do you need? At what speed, loads, and temperatures? What duty cycle are you doing? Are you just going to be driving a passenger car around town? Are you pulling 500 tons in the back of a dump truck? What the heck are you doing? Those are the requirements. We bring those and decompose them into much smaller bits and pieces, but then we have to plan for risks. How can this go wrong? How can this function not happen? And what's the solution? What's it look like? Is it an engine? Is it a battery pack? Is it, whatever it is? And then what's the testing that we do, both in the analytical space with all of these fancy physics tools, and in the test space with actually building stuff and taking it out on the road and driving it in Bemidji to see if it'll start at 20 below, right? So we do that. It's the same pattern, but so you can actually leverage that. As opposed to this n-squared matrix at the bottom, which is a from to type of thing with the arrow there, is I'm going from this information flow pattern to this other one. That's actually the same information as that top V. It's just in a different format and much deeper level. So again, if I showed you those bottom Excel tab charts, you'd be like eyes glazed over. It's like, I can't deal with that. But the other stuff hopefully is a little simpler to understand. But we can actually start bucketing those things and put them in place. Next principle. Perspectives. So in your 2 to 5 team group, do you guys all have the same perspective on the problem or solution? No. I think for your teams, you guys are intentionally mixed funky, right? No, not yet? Maybe that'll come the second half of the semester. At least I'm told, maybe. Did you self-form your teams, or was it kind of random? Random? Okay. So one of the things is different perspectives. It's really kind of handy. I'm going to give you a story here about an actual engineering problem that we have at Cummins. And so this was a set of functions for an exhaust manifold. Combustion engine is going up and down. We've got to get the exhaust out of that manifold and out the tailpipe. So here's a functional flow breakdown of, I need to manage the exhaust flow combinations and splits. A child of that is I need to connect and branch the exhaust flow. So this is for a large engine. I need to bring all of that exhaust and put it together, kind of like headers for your car if you're a gearhead, right? So I need to transfer the exhaust flow from the engine to the tailpipe. Let's see, I need to inhibit the heat transfer to the ambient, meaning I don't want the heat to escape the exhaust pipe. We actually have after treatment on our exhaust that helps take care of the particulates and the nitrous oxides, and we actually do treatment of the exhaust so that at the tailpipe of a diesel engine, one of our diesel engines, it's primarily water vapor.